Today in geometry, we are starting chapter 8.1, finding angle measures and polygons. So first, let's recall what a polygon is. So a polygon is a closed plane figure formed by 3 or more segments that intersect only at their endpoints. Consecutive vertices in a polygon are 2 vertices that are endpoints of the same side. Remember that consecutive means one right after the other. The diagonal of a polygon is a segment that connects any 2 non-consecutive vertices. So in this picture here, we're going to label our consecutive vertices and our diagonals. So they tell me that the segments are AB, BC, CD, DE, and EA. So the consecutive vertices of segment AB would be point A and point B. Of BC would be point B and point C. CD would be point C and point D. Segment DE consecutive vertices would be segment or point D and point E. And consecutive vertices of EA would be point E and point A. So now we're going to list our diagonals. They are what's drawn in the dotted lines. So if we start out at vertex A, we have diagonal AC and diagonal AD. If we move up to point B, we have diagonal BE and BD. And then we go to C, we already have AC, so we just need EC. So those are our diagonals. And they are segments, so that's why we put the segment bar notation above them. The interior angles, remember interior means inside. So the interior angles of a polygon are the angles at each vertex on the inside of the polygon. In convex polygons, each interior angle is always less than 180 degrees. In a triangle, okay, so it tells us that some interior angles are well known and are easy to find. In a triangle, we already know that all 3 angles inside a triangle have to add up to equal 180 degrees. We know that a regular triangle means that it's equilateral with all sides and angles equal measure. Therefore, 180 divided by 3 tells me that each angle is 60 degrees. A quadrilateral, when dealing with 4-sided polygons, we can draw a diagonal that divides the figure into 2 triangles, showing that the sum of the interior angles must be 2 times 180, since I have 2 triangles. So 2 times 180 is 360 degrees. The strategy shown in the quadrilateral of dividing the figure into triangles will be used to investigate the interior angles of polygons with more than 4 sides. This strategy may be referred to as partitioning or dissecting. If we use diagonals to partition a polygon into a series of triangles, as we did with quadrilateral, we can calculate the sum of the interior angles of larger sided polygons. So in the back, we're going to take a look at that. In a regular hexagon, 4 triangles can be created using diagonals of the hexagon. So we would do 4 times 180 degrees and get 720 degrees. The same approach can be taken if it's an irregular hexagon. We still would draw 4 diagonals, get 4 triangles. 4 times 180 is 720 degrees. And then it says, notice that the sum of the interior angles is the same for both regular and irregular. Also notice that we formed 4 triangles in the hexagon, which is 2 less than the number of sides of the polygon. So the hexagon has 6 sides. We were able to form 4 triangles. That is going to hold true for every single polygon. Therefore, we can come up with a formula. The sum of the interior angles is always 180 times n minus 2, where n is the number of sides. So that's what this great big one is. Okay? We need to know this formula. Sum of the interior angles of any polygon is n minus 2 times 180 degrees. If you know that the polygon is a regular polygon, remember that regular means all sides and all angles are the same. You can find each interior angle by dividing that by the number of sides. So each interior angle of a regular polygon is 180 times n minus 2 divided by n, again where n is equal to the number of sides. But then it says beware, you cannot use that formula to find each angle in an irregular polygon. Okay? Now let's talk about exterior angles. So the exterior angle of a polygon is an angle that forms a linear pair with one of the interior angles of the polygon. In the same manner as an exterior angle of a triangle, the exterior angle of a polygon is formed by any side of the polygon and the extension of its adjacent side. So then let's look at this picture. The exterior angle of a polygon formed by any side of the polygon and the extension of its adjacent side. So if I were to extend AB, I would make an exterior angle right there. If I were to extend BC, I get an exterior angle. Extend CD, there's my exterior angle, and we can do that all the way around. If you add all exterior angles, one at each vertex, you will get a sum of 360 degrees. The sum of the exterior angles of all polygons is a constant 360 degrees. If you know that the polygon is regular, you can find each exterior angle by dividing by the number of sides, n. Remember that exterior angles of a regular polygon are congruent. And so next page, those are these formulas. Again, we want to memorize these formulas. Okay? So now we're going to start doing some examples. It says, find the sum of the measure of the interior angles of a convex polygon. So this is where we do the n minus 2, number of sides, minus 2 times 180 degrees. So first we just need to figure out how many sides do we have. So this first one, we have 8 sides, which is known as an octagon. So we would say 8 minus 2 times 180 degrees. So 8 minus 2 is 6. 6 times 180, 1,080 degrees. This next one, we have 7 sides. Remember that 7 sides is either known as a hepta or a septagon. So I would say 7 minus 2 times 180, which is 5 times 180, 900 degrees. The last one, count up all the sides. We have 12 sides. That is known as a dodecagon. So we would do 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1,800 degrees. So that's how we would find the measures of the interior angles of those polygons. So now let's look at specific ones. So number 2, find x. So I see that I have a quadrilateral. So I know that 4 minus 2, because that's 4 sides times 180, all 4 angles have to add up to equal 360. So then we're just going to set this up. So x plus 108 plus 121 plus 59. So I'm going to add up all my angles. They have to equal 360. When I add all those up, I get x plus 288 equals 360. I'm trying to solve for x, so subtract 288 from both sides, and I get x is equal to 72 degrees. It's an angle, so we keep our degree sign. Number 3, these are exterior angles. Remember that the sum of all exterior angles, no matter how many sides, is equal to 360. So we're going to add up all of these exterior angles and set equal to 360. So 2x plus 89 plus 67 equals 360. Here I have 2x plus x, so I'm going to combine like terms. I get 3x. 89 plus 67 gets me plus 156 equals 360. We're solving for x, so subtract 156 from both sides, and we get 3x equals 204. Finally divide by 3, and we get the x is equal to 68 degrees. Number 4, it says find the number of degrees and the sum of the interior angles of a decagon. Again, we're using the n minus 2 times 180. So decagon has 10 sides. So 10 minus 2 times 180. 10 minus 2 is 8. 8 times 180 is 1,440 degrees. We're finding degrees, okay, the sum of the degrees, so we always have our degree sign. And the number of degrees in each interior angle of a regular pentagon, okay? So here it says each interior angle regular pentagon. So this is where we do the n minus 2 times 180 divided by n. Pentagon has 5 sides. So we would say 5 minus 2 times 180, all that divided by 5. So 3 times 180 divided by 5, 108 degrees. So each interior angle of a regular pentagon is 108 degrees. Number 6, find the sum of the exterior angles of a hexagon, then of a pentagon, of a dodecagon, of a quadrilateral, and then of a 17gon. Remember, what are we finding? The sum exterior angles. The sum of exterior angles for any polygon, no matter how many sides, is always 360 degrees. So that was a trick question. No work to do. Just remember that it's always 360 degrees, the sum of exterior angles. So now number 7, it says find the measure of each exterior angle of a regular octagon. At the top of this page, we had that formula that said the exterior angle of a regular polygon was 360 divided by n, where n is the number of sides. An octagon has 8 sides. So on this, all I have to do is 360 divided by 8, and I get 45 degrees. Turn it over for the last of our examples. Number 8, the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. It tells us we're going to use the polygon interior angles theorem to write an equation and solve. That theorem is n minus 2 times 180. That equals the sum of the interior angles, remember? So we're going to say n minus 2 times 180 equals, they told me it was equal to 900 on this problem. So if the sum is equal to 900, we want to know how many sides does it have. So here we're going to solve this equation for n. So first we want to divide by 180. So then we get n minus 2 is equal to 5 when I do 900 divided by 180. Now all I have to do is move my 2 over. So 5 plus 2 and equals 7. So it has 7 sides, but it says classify the polygon. Remember, classify means give its name. So 7 sides is either a heptagon or a septagon. Remember, this one has 2 different acceptable names. So it would be a heptagon or a septagon that has interior angles sum of 900 degrees. So number 9, the sum of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by the number of sides. So the same thing, we're going to do n minus 2 times 180 equals 1440. Divide both sides by 180 because we're trying to get n by itself. So now I have n minus 2 equals, so 1440 divided by 180 is 8. Add 2 to both sides, so I get n equals 10. So it has 10 sides. A 10-sided polygon is known as a decagon. Number 10, find the measure of each interior angle of a regular dodecagon. So this is where we do the n minus 2 times 180 divided by n. Dodecagon has 12 sides. So we're going to do 12 minus 2 times 180. Then we're going to divide that by 12. So 12 minus 2 is 10. 10 times 180, 1800. Divided by 12, 150 degrees. And the measure of each exterior angle of a regular dodecagon. Again, dodecagon has 12 sides. This time that formula is 360 divided by n. So 360 divided by 12. Each exterior angle of a dodecagon is 30 degrees. Number 12. Each interior angle of a regular entagon has a measure of 156 degrees. How many sides does the polygon have? Very first thing we want to do is find the exterior angle. So this is the easiest way to do this. So find your exterior angle. Remember that interior plus exterior equals a linear pair, which is 180 degrees. So we're going to say 156 plus the exterior equals 180. So my exterior angle, do 180 minus 156 is 24 degrees. So now we have that equation, 360 divided by n is equal to my exterior angle. We just found our exterior angle to be 24. So 360 divided by n equals 24. I have a proportion because that's really like 24 over 1, so we cross multiply. We get 24n equals 360. So divide by 24. And we find that n is equal to 15. So it has 15 sides. And what we have actually done is created a new formula that we can learn. This new formula says that the number of sides is equal to 360 divided by the exterior angle. So we want to know that one as well. And so we're going to use that for number 13. Number 13 says each exterior angle of a regular pentagon has a measure of 9 degrees. How many sides does the polygon have? So we're going to use that formula we just came up with. So 360 divided by 9 is equal to 40. So this polygon has 40 sides. It would be known as a 40gon. All right, so that is section 8.1, our angle measures inside polygons. Your homework is worksheet 8.1a. You can find it on Canvas. I do not have that printed off for you. You're going to do number 2 through 40 even, so you're only going to do the evens.